In the last video for Unit 3, Learning Set 3, we're going to look at determining which regression line or curve best fits the data. So this lesson opened with a discussion about a $100,000 loan with an APR of 7.5% taken out in January 2010 for a period of 15 years. So examine the table of decreasing loan balances over a 15-year period using regression to determine a curve of best fit for this data. So instead of using a graphing calculator, we are going to use an online graphing calculator. We're going to use Desmos. And Desmos has the ability to enter data into a table. Most of you have just put in equations, but on Desmos, you could actually hit that plus sign, and then there is a table option, and you can take this data and enter it into the table. Another way you could do this, if you have this data in, like, say, a Google Sheet or a table in Word, you could copy it and just paste it in there. Okay? So let's look at the Desmos on this. So what I did was I did the plus, selected table, and then I typed in all of the data into this table here. Okay? And from there, what you would do is you would put in the equation to find, and we're going to look at linear, quadratic, and cubic to see which sort of line fits the best. Now, with linear, we know that the base form of linear is y equals mx plus b. Well, notice I have this little 1 here after the y and the x, and I have this little tilde mark. Well, this little tilde mark says find the line of best fit. So looking at the graph, I would go down to the next box. I would type in for the linear y, this little tilde mark. Now, if I do y tilde mark mx plus b, nothing happens, okay? And the reason this is if we scroll back up to the top, if we look at the top of the table, it automatically labels it with x sub 1 and y sub 1. So if I go down here and after the y, I type 1, it will put it in the lower position for us. The same thing with the x. And watch, once I put the sub 1 in there, it automatically fits the line the best that it can to the data and plots it. And then it gives us this information here. And the parameters are what we would fill into our equation. So y equals mx plus b. M is negative 6777.54, and B is 110,001. So we would actually put that into our equation here to get y equals negative 6,777.54x plus 110,001.04. Okay, and for quadratic and cubic, we would do the same type thing. So quadratic has the format y equals ax squared plus bx plus c. So going back to Desmos, on the next line down, I'm going to do the y1 because it's y sub 1 tilde ax and do my squared and then my 1, and it will make it a sub 1 plus bx sub 1. And I'm not doing anything special to get it to go down to the lower 1. I'm just typing 1 after the x, and it's recognizing that it goes into a sub position, plus c. So if we look at this, we can already see our green line for our quadratic is fitting our points slightly better than our blue line, okay? And like the linear format, In the quadratic format, it gives us parameters and it gives us values to put in for A, B, and C, so that way we can write our equation. And these are just the values from the Desmos. So cubic, if you're following along, linear has a exponential value of 1. Quadratic starts with an exponential value of 2. So if you remember from Algebra 2, cubic starts with an exponential value of 3. And you just take your letters and you continue on. Ax to the third, bx squared, cx plus d. And we would take and put that in our Desmos. So y1, the tilde mark, ax cubed sub 1 plus bx squared sub 1 plus cx sub 1 plus d. So if we look a little closer, I'm going to turn off the blue line and I'm going to turn off the green line. Look at the purple line compared to the green line. And you notice that the purple line fits just a little bit better. Okay. And also in the statistics section, if you look at the statistics section, it has this R squared value. And the way that works is the closer to 1 that number is, the better the fit. So with our linear, we had a 0.98. With the quadratic, we had 0.998, which is a little closer to 1 than the linear. So we know the linear isn't the closest. And then when we look at the cubic, it had an R squared value of 1, which is what we really wanted because it is the closest value, which it is 1. So that is the best curve fit for this set of data. And then, like before, the parameters list the A, B, C, and D. So we would just go back to our equation and put in the A, B, C, and D values. Now, you notice like this is minus 101.67. Looking at this, the minus, I just took and put the minus in there instead of putting it as a plus, negative. Okay, so let's look at another example. So use the linear, quadratic, and cubic regression equations determined in the previous example to compare the computed loan balances when x equals 2. So with the loan balance amount given in the chart for 2011. So for the linear, we would just take our linear equation we wrote on the previous page, put 2 in for x, and we would get $96,445.96. Doing the same thing for quadratic, we use that equation, put 2 in wherever there was an x. It's $92,093.62. Cubic ends up being $92,190.73. So using what we learned from the previous example, when we look at our Desmos, we know that this purple line, the cubic one, is going to be the closest guess on that piece of data. Okay, so in the chart, it says $92,206.05. So this, like we just stated, the cubic regression line comes the closest to being the same amount as what is shared in the table.